So part B, again, as I stressed earlier, in problem 13 is different than part A because we have to use basic reagents in this case. So here's our original equation. And again, we need to balance half reactions. So on this side of the equation, we have 4 oxygen atoms, and on this side we have 2 oxygen atoms. So this is the side of the equation that we're going to have to add H2O to. And again, since we're adding H2O, not only are we adding oxygen, but we're adding hydrogen. So we have to balance the hydrogen by adding H plus to this side of the equation. All right, so we've got 4 oxygen atoms here, and we have 2, 3 here, so we need 1 more on this side. And then we would have 4H plus. Now to balance charges, okay, so we have to add 3 electrons to this side of the equation to balance that plus 3 charge acquired from the hydroxide ions in order to have a net charge of 0. Since we have 3 electrons for this half reaction, we have to multiply the entire half reaction by 2 in order to get a total of 6 electrons on both sides of both of the reactions. Okay, now to balance the other half reaction, so again, there is oxygen on this side of the equation, and that means we have to add water to this side of the equation. But of course, we have to add H plus on this side. Okay. So it seems that everything balances except the hydrogens, so we'll just add 2 to this side. So here we have a charge of -1. Here we have a charge of +1. So to make the charges equal on both sides of the equation, we have to add 2 electrons to this side. And we need to balance this. So we have to multiply both sides of the reaction here by 3, so we also get 6 electrons, so we can balance the other half reaction. Okay, so let's write these reactions out. Okay, so this is where it may get a little tricky, but if you just follow along, you'll be fine. So we can cancel out the 6 electrons, right? Now if you notice, the difference between the basic solution and the acidic solution is that there should be OH minus in the reactions. However, there is none. There's actually H plus. But what ends up happening is that the OH minus ions will end up neutralizing the H plus ions that are formed, because H plus actually gets formed in the solution, however it gets neutralized by OH minus. Now, before we get to that part, we can first cancel out the H pluses and the H2Os from either side of the equation. So we have 6 H pluses here, and we have 8 H pluses here. So what we can do is we can subtract 6 H plus from both sides of the equation, and we're left with 2 H plus. Now, we have 4 H2Os on this side of the equation and 3 H2Os here. So we can subtract 3 H2O from both sides of the equation, and we're left with 1 H2O here. Okay, now let's clean this up, shall we? Alright, so after we've cleaned up our equation, we will end up with 2MnO4 minus plus 2H plus 3 CNO minus. Remember, that water molecule is no longer on that side. Then we have 2MnO2 plus H2O plus 3 CNO minus. CN minus, CNO minus. Cool. But now remember what I told you before, how we are in basic solution and we should not have any H plus ions, but we do, as you can see. Well, again, what ends up happening is H plus ions will get neutralized by 2 OH minus ions. And what that creates is 2 water molecules. But remember, since we added 2 OH minus ions to one side of the equation, we have to add 2 OH minus ions to the other side of the equation. We also have to cancel the water molecules out from both sides. So we'll subtract 1 from here, subtract 1 from here, and our cleaner equation will look something like this. Hope this helped.